Hey folks, this is your error analysis for Learn Check number 6, Solving Quadratics. Let's start off with question number 1. So question number 1, we want to know the solutions. Remember that solutions are your x-intercepts of this function. This function is written in factored form. We know that it's written in factored form because we see the parentheses here, and those parentheses are being multiplied together because there's no sign in between. So if we're going to go from factored form to solutions, we just need to remember to take the factors and set the factors equal to 0, then solve. Or if you were having trouble with remembering that, you could have also graphed this equation, the factored form equation, you could have graphed this in Desmos. And if you graphed it in Desmos, then you could have matched it also to the picture. Also, if we're working smarter and not harder, we would see that there's a negative in front. Remember how we talked about how if the leading coefficient is a negative, that if it's negative, the graph is going to open down. If your leading coefficient is positive, it's going to open up. So right there, this could have also helped us a little bit to eliminate answer choices C and D because these are opened up. A and B are opened down. So that could have helped us. Either way though, we're going to take these factors and set these factors equal to 0. Technically, one of my factors is -1 is equal to 0. The next factor is x plus 4 is equal to 0. And our last factor is x minus 2 is equal to 0. This one has no x, so can't use that one to solve. This though, -4 minus 4, so that means that x is equal to -4, plus 2 plus 2. Again, we're using inverses here, so that would mean that x is equal to 2. So these are our two x-intercepts. So if I was going to compare these, notice how this is a -4 and this is a +2, while this one is a -2 and a +4. So as long as I'm paying attention to my signs, then I should be able to pick A as my answer choice. Again, if you kind of forgot about these things, we could have easily taken this and typed this into Desmos and graphed it and compared the graphs to also get this answer choice. All right, let's look at the next question. So number 2, which of the following are true of a quadratic function whose discriminant is 0? To receive credit, you must select all true statements. So this one, we had to understand what it meant for the discriminant to be 0. So if you remember that we had kind of like 3 rules. So we had if the discriminant was a positive number, if the discriminant was 0, and if the discriminant was negative. So when it was discriminant was 0, we had to remember that this would be a bounce. And we would normally say that there is one real solution, and that's because we would have a duplicate. So for example, we might get x is equal to 2 twice, or x is equal to 5 twice. But whatever that solution is, it's a duplicate, which is why it looks like one real solution, because it bounces off the graph. So, looking at our answer choices. All right, A and B are going to take some work. Now, we could actually solve for the discriminant for these. Like we could say like the discriminant is equal to our b squared minus 4 times a times c. So we could do that. Or remember that the graph is going to have a bounce. So that means the graph could either look something like maybe like this, where it like just touches that one time, bounces there, Or maybe it's like this, something that just touches the x-axis one time and then goes the opposite direction, just a bounce. So I would personally graph these. I think that is a better use of our time. Again, you could solve for the discriminant for both of these. That would take a little bit more time, but I mean, you could do it. So x squared minus 10x plus 25. So notice how this one is a bounce. It touches and then comes back up again. So A definitely has to be true here. All right, and then let's do the other one. So -4 and then 9. Now see how this one doesn't touch the x-axis whatsoever? So this can't be the graph for a discriminant that's 0. This would be a graph for a discriminant that is a negative number, but not one that's 0. Okay, so that means we know that B cannot be an answer. Okay, C, double root. Yeah, double root, because double root is that whole duplicate. It's just another word to describe the duplicate part. Okay, so for sure C. Okay, the function has 2 real discrete roots. So discrete means different. So does this graph have 2 different roots? No, because remember we said that the 2 roots were going to be duplicates of each other? They're not going to be like different. They're going to be the same. So that can't be it. All right, E, the graph has no real x-intercept. Well, we literally just graphed it and we could tell that it touched the x-axis. So remember, if it has no real, that means it doesn't touch. But when we graphed, like this one right here, it touched. And we talked about how it has to have like a bounce and one real solution. So that means if the discriminant 0, it's got to touch. So that can't be it either. So to receive full credit, you would have had to answer both A and C. All right. Number 3, using factoring by grouping, solve the quadratic. So we were very specific with the method that we would like you to use, and also making sure that you're showing work for organization, X method grouping, the structure for factored form, and how to go from factors to solutions. So again, we're going to use factoring by grouping, and then we're going to solve this. So first thing we need to do is get this into standard form. So subtract 10, subtract 10. So 0 is equal to 3x squared minus x minus 10. All right, after standard form, I'm going to check for a GCF. Notice in front, this is positive, so I do not need to divide by a negative. And I can't divide 3 and -1 and -10 by a common number. So for this one, there's no GCF. So I do know then that my A is 3, my B is -1, and my C is -10. So let's go ahead and set up our X method. So -30 and -1. Coming up with side numbers, I would come up with 5 and 6. And in order to get a -1, excuse me, the 6 has to be negative. So remember, multiply to the top and combine to the bottom, and making sure that we get that -1 there. So these side numbers are now our B term. So if you can imagine us taking this, and we are going to not use this one, but instead use these, and we're going to make sure to put x's with them. So we're going to have 3x squared I'm going to go ahead and write negative 6x with it because I think the 3 and the 6 go better together. I'm going to leave a little bit of space here, and then I should have 5x and then minus 10. So remember, it does not matter the order that you put your side numbers in as b terms. And I'm getting ready for grouping, which is why I left some space here. All right, I need a GCF per group. For this first group, I can definitely divide by 3, and both of these have an x. So my GCF is 3x, and once I divide, I'm left over with x minus 2. All right, with the next group, I can divide both of these by 5. And once I divide, I'm left over with x minus 2. I know I did this correctly because my leftovers match. All right, I'm going to bring my GCFs together. I'm going to have 3x plus 5. And then I'm going to write one of my leftovers, x minus 2. So technically, we're still equal to 0 since that was originally equal to 0. Remember that this is our factored form. Now, I've got the factors, but now I need to get to solutions. So if we remember that our factors get set equal to 0. So again, I'm going to take 3x plus 5 and set that equal to 0, and then x minus 2 and set that equal to 0. All right, so I need to solve for x, and if I'm solving, I'm doing my order of operations in reverse. So I'm going to start with adding and subtracting. 5 is being added, so that means I'm going to use the inverse, so subtract 5. 5 minus 5 is 0, so I have 3x is equal to 0 minus 5 is negative 5. And then 3 is being multiplied with x, and the inverse of multiplication is division. So that would mean that one of my solutions is x is equal to negative 5 over 3. All right, let's go to our other factor. So x minus 2 is equal to 0. Inverse of negative 2 is plus 2. So that would mean that my other solution is x is equal to a positive 2. And this is our final answer. All right, number 4. So using the quadratic formula, prove that I'm not going to read it out loud, but those are solutions to this equation. So notice with this one, we gave you the answer, and we wanted you to really just show the work of how to get that answer. Now, please realize that this is a way for us to get you to focus on the process and not just the answer. And if your process did not match the answer, then you did not get full credit. So we have 4x squared plus 4x minus 8 is equal to 1. All right, so we're going to use quadratic formula. Excuse me, we get to solutions. So even though this is the quadratic formula, I still need to make sure that we are in standard form. So I'm going to easily do that by subtracting 1 and subtracting 1. So that would mean that we have 4x squared plus 4x, and that's going to be minus 9 is equal to 0. Our A is 4, our B is also 4, and our C is negative 9. All right, so with the quadratic formula, I first need to start with my discriminant. So D is equal to B squared minus 4 times A times C. So my B is going to be 4 minus 4 times 4 times negative 9. You can use a calculator for this, but you can also do some of this in your head. So 4 squared is 4 times 4, which is 16. Now, right here, I've got 3 numbers being multiplied. A negative times a positive is still a negative, but then a negative times a negative is going to be a positive. So I'm going to go ahead and put a plus sign right here. I do know that 4 times 4 is 16. And at this point, I'm probably just going to pull out a good old calculator here. So 16 and then times 9 is how we get 144. And then 144 plus 16 is going to give us 160. So our discriminant is 160. All right, I'm not done yet. I now need the rest of my quadratic formula. So it's going to be x is equal to the opposite of whatever b is, plus or minus the square root of your discriminant, and then divided by 2 times a. So let's fill in our information. So first parenthesis should be our b, which is 4. Underneath the radical is 160, and then a, which is 4. All right, let's get this cleaned up a little bit. So x is equal to negative 4 plus or minus. I'm going to divide this by 8. Now the radical. Remember that we need to simplify this radical, and normally I pull that off to the side. All right, let's break this down. 160 is not a perfect square, but I can break this down into 16 and 10. 10 can be broken down into 5 and 2. These are both prime, so I'm going to circle them. 16 can be broken down into 4 and 4. Now, even though 4s are not prime, remember I'm looking for 2 of any number. Now, 16 was a perfect square, which is why it breaks down into 4 and 4. So remember, if I have 2 of a number, only one of them are going to go on the outside. And then any numbers that do not have pairs stay on the inside. They're being multiplied. So when I simplify this, this is 4 times the square root of 10. Now, if you wanted to check yourself, you could put square root of 160 in a calculator, and you could also put 4 radical 10 to a calculator, and they're going to give you the same decimal answer, so you would know that they're correct. I'm going to put this back into my quadratic formula, so 4 radical 10. All right, now it's time to simplify. So remember, we're going to ignore the radical, and we're just going to look at these 3 numbers, and we're going to see if we can divide them by a common number. Well, we can divide them all by 4. So that would mean negative 4 divided by 4 is going to be negative 1, plus or minus 4 divided by 4 is 1, but I technically don't need to write a 1 in front of the radical 10. You can if you want. And then 8 divided by 4 will be 2. And if you had gotten me to this, then that's how that matches to this, because remember that 1 is a plus and 1 is a minus. So you can leave it like this, or you can write it as 2 separate solutions. All right, last but not least, number 5. So again, we're going to be using quadratic formula to find the solutions of this equation and writing this in radical form. So making sure we're following directions. So 4x squared is equal to 8x minus 9. Again, this has to be written in standard form. So it really doesn't matter whether you move the 4x squared or whether you move the 8x minus 9. It might look different at first, but you're going to get exactly the same answer. I'm going to go ahead and move the 8x and the 9 just because I normally like for my a to be positive if possible. So minus 8x and add 9. Now none of these can combine, so I'm just going to rewrite this as 4x squared minus 8x plus 9, and that's equal to 0. Our a is 4, our b is negative 8, and our c is 9. All right, we need to find the discriminant. So I know I need discriminant is equal to b squared minus 4 times a times c. So -8, 4, and 9. All right, -8 squared. So it's going to be 64 because a negative times a negative is a positive, and then 8 times 8 is 64. Now, these numbers just happen to be very similar compared to the last problem, but make sure you're checking the signs. This is a -4, but I'm multiplying a negative number by two positive numbers, so it's going to stay negative. And we know that 4 times 4 was 16, and if you remember from the previous problem, 16 times 9 was 144. But now we're going to need to take 64 and subtract that with 144, and we get a discriminant that is a -80. All right, so quadratic formula time. X is equal to the opposite of b plus or minus the square root of the discriminant divided by 2 times a. All right, so our b, again, is this -8. Discriminant is -80, and our a is 4. Don't get tripped up with having two negatives here. That's okay, because a negative times a negative is a positive. Plus or minus, and we're going to be dividing this. 2 times 4 is 8. Again, we are going to take this radical to the side, and we want to simplify this. Now, some of us might forget this, and this is a big thing. If there is a negative underneath, remember that we cannot take the square root of a negative number. That is going to cause an imaginary number. So it's going to be an I that's in front of the radical. And then let's break this down. So we can break down 80 into 8 and 10. This can be broken down into 4 and 2. 2 is prime, I'm going to circle it. 10 can be broken down into 5 and 2. 4 can be broken down into 2 and 2. Remember, we're looking for pairs of two numbers because, again, this was a square root, an index of a 2. So I know I'm going to have the I that is outside. I'm going to have a 2 from this set of 2's. I'm also going to have another 2 from that set of 2's. I still have the radical because there's a 5 left over. So once I simplify this, 2 times 2 is 4, so 4i radical 5. And that is going back in our quadratic formula. So 4i radical 5. All right, again, we want to simplify, ignore the radical. We're going to simplify. So is there any number that's in common that we can divide by 8, 4, and 8? Yep, we can divide by 4. So that means that 8 divided by 4 is 2. Plus or minus 4 divided by 4 is 1. I'm not going to write the 1 because it's in front of the I, but I am going to write the I and then radical 5. And then we know 8 divided by 4 is 2. You can leave it like this, or you could have written it in two solutions as 2 plus I radical 5 divided by 2, and x is equal to 2 minus I radical 5 divided by 2. Either answer would be considered acceptable. All right, make sure to answer your questions as you're moving through the video. And if you need any extra help, make sure to talk to your teacher. Have a great one.